Welcome back, everybody. We're going to do another science experiment today. The topic today is how different materials have a different capacity to absorb heat. Now, we saw in the previous demonstrations what heat is all about. Heat is about taking an object that has molecules in it, and the molecules are always vibrating a little bit. When you add heat to that object, it imparts energy to the molecules vibrate a little bit more, they move a little bit further apart, the material will tend to expand. That's sort of what we saw with atmospheric pressure previously. So now I'm going to demonstrate different materials' capacity to absorb heat. Different materials will expand and their molecules will vibrate at different degrees, demonstrating their different ability to absorb heat. So, the first thing I'm going to show you here, and maybe Davis will help with the demonstration. I only do this under parental supervision. But here, no, not yet. Pyromaniac here. Here is a balloon filled with air. Now, Davis is going to apply some heat to it in the form of a flame, and we'll see what happens to the balloon.
Woo!
As expected. Now, here is the same balloon made out of the same plastic material filled with water. Now, Davis, if you could apply the same flame. Mom's getting nervous. What is going on? Why is the balloon not popping? Smelling a little bit, but it's not popping. Okay, but thanks. Now it's discolored a little bit on the bottom, but you can actually wipe that off. There's actually no distortion of the balloon. And you know why that is? Davis, do you know why that is?
Because the water is absorbing the heat.
The water is absorbing the heat so efficiently that there is no time for the heat to pop the balloon and break the plastic. In fact, you could hold that flame up to this balloon all day long until the water inside starts to boil, and the balloon will still not pop. Now, we have another demonstration here to show you the ability of different materials to absorb heat. Now, as you can see, there's a metal ball on the end here. Oh, and here's Sophie, come on up. There's a metal ball on the end of one, and there's a metal ring on the end of other. Sophie, can you put the metal ball through the hole, the ring, the metal ring? It goes through, correct? Correct?
Yeah.
Now, what we're going to do now is apply some heat to the metal ball. Now we're going to turn on the gas here.
Okay,
now why don't you pop over there, Sophie, and hand me the ring and put that ball right on the heat there. Hold it right on the heat. Now this should take about, I don't know, 30 seconds or so. Apply it right there to the heat. Now what do you think is going to happen? Think in your own mind. What do you think is going to happen when heat is applied to this ball? And I'll speed this up or do a little cut to avoid the time it takes to heat up the ball. You might also cut out Sophie picking her nose.
Oh, we didn't even, well, I guess we sort of saw that.
All right, should we try it now?
Just don't touch
Is it hot enough? Okay, let's see, Sophie, if it goes through the ring. No, it does not. Will not go through the ring. Now you had to push it.
Oh.
You had to push it. Get it a little hotter. Put it over
All
here.
right. Ooh.
We'll just wait, and I could zip through this, but we'll wait another 15 seconds or so. Turn it around. Rotate that a little bit. Okay, now give it a try. See if that goes through. Oh, it won't go through, and no push as she might. She can't get it through this time. All right, now, it's super hot. It's super hot. Not in my crotch. I get it. Now, we're going to put this over here, and I'm going to put some water on it.
How did I do that?
Okay. We'll cool it down.
Hands
I'll put
break.
it in the sink. Now, the next thing I want to show you is that how this principle can be applied in real life. For example, you may have seen your mom and dad have difficulty opening up the lid of a jar. So if you have a glass jar and you have a metal lid, The reason running it under hot water will help you to loosen this is because the metal has a different capacity to absorb heat than the glass. The metal absorbs heat, as we saw,
It softens the metal.
pretty efficiently and expands the lid. It expands the lid of the metal top. The glass has a less capacity of absorbing heat, so that stays about the same while the lid expands a little bit and it's easier to open up. Now, another thing you see in real life that demonstrates this principle, and this is more for the moms and dads, you may have noticed in your mom's and dad's car, there's a little instrument that tells you when you need to refill your car with gas. Once your gas gets down to a certain amount in the tank, there's a certain level, and if the gas goes down below that, it triggers a little red light that says time to get some gas. Now, in the summertime, what do you think happens to the gas? Well, you fill up 2 gallons into your tank, exactly 2 gallons in the summer. And if you filled exactly 2 gallons into your tank in the winter, which tank would have a larger volume of gasoline?
Winter. In the winter.
No, would not be winter.
Summer.
It would be summer. Now, why is that? In the summer, it's warmer. And when it's warmer, things expand. So you put 2 gallons of gasoline in the tank. Now, it's going to go up a little bit further than 2 gallons would in the winter. Now, as you use the gasoline and your gasoline gets down to the point which triggers the light that says, hey, time to get more gas, this is going to be a larger volume, but it's still just going to have the same amount of energy in the gas. Meaning, in the summer, you better get to the gas station quicker than you would in the winter when you see that same light go on. Because here, the volume is greater, but the energy is the same as it would be, so it triggers this line a little bit later than it would in the winter. Same amount of energy in each of the 2 gallons of gas, but one is a larger volume than the other. Now, also, this principle demonstrates why the Patriots did not cheat in what is called Deflategate. In fact, I will link to somewhere in here a longer lecture by an MIT professor that shows that the reason the Patriots footballs were less inflated on the field where it was cold and wet than they were when they were inflated inside the stadium is because of what's called the ideal gas law, which is just a formula that describes exactly how the gas will deflate when exposed to colder temperatures. Just what we saw here. It was inflated in a warmer environment in the stadium. When it was brought out into the colder weather, it deflated a little bit. And that principle exactly explains the differences in the pressure on the balls on the field and the balls inside the stadium. So that is my little talk on the principles of different materials being able to absorb heat at different rates. Hope you enjoyed it. And we'll do another one sometime soon.
Bye. Hi.
Oh, also that same principle also describes why places where people live closer to the water tend to be more temperate climates. They're less warm because the water nearby absorbs so much of the heat. The temperature in the area is generally cooler than it would be otherwise. When you live more inland, away from large bodies of water, temperature tends to be warmer because there's no water there to absorb the heat as efficiently as we saw earlier in our demonstration. All right, everybody, it's a little bit later in the day, and I have another demonstration of the power of various substances to absorb heat. Now, Davis today forgot to shut off the water in the bathroom, and we heard this water trickling down the drain. I said, Davis, that's money going down the drain. So I said, Davis, give me 20 bucks. So in here, in this cup, is a mixture of water and alcohol. Alcohol is very flammable. Now water, as we saw earlier though, absorbs heat very efficiently. So what I'm going to do, since Davis likes destroying money by pouring it down the drain, I am going to dip this in this solution of ethyl alcohol. Actually, it's a different type of alcohol. And water. It's an actual $20 bill. And let me, as you can see, now of course it's a crime to destroy legal currency. But since Davis likes destroying money, we'll just destroy it. Wait a minute, what happened? Let's try that again.
Oh, what their stupid power. All it does is just like.
There we go. Let's destroy that $20. Wait a minute. Why is it not burning? Now, of course, it's not burning because while the alcohol is flammable, the water is immediately absorbing the heat. So that the temperature of the $20 bill never gets over 451 degrees Fahrenheit. Now, you know what 451 degrees Fahrenheit is? That's the temperature at which paper burns. The title of a classic Ray Bradbury science fiction novel called Fahrenheit 451 is about a bunch of evil fascist guys that burn books. And books burn paper burns at 451 degrees Fahrenheit. But we'll try this one more time and see if I can destroy this $20 bill. But I think the ethyl alcohol, while it will start on fire, the remaining water will preserve the $20 bill. There we go, and it worked again. The water foiled me. Anyway, that's our concluding aspect of the science experiments for the day. See you later.